Hello and welcome to 5 Minute Math. Today we are looking at lessons learned from the third grade STAAR test 2023. My name is Aaron Daffern and I am the creator of the 5 Minute Math series. What we are doing is we are looking at how each student did across the state of Texas on the readiness standards that they scored 50% or low on collectively. So these are the difficult readiness standards, and we will use the statewide item analysis report to try to make some inferences as to not only why they got these items wrong, but what we as educators can do differently as instructors. So let's start with 3.5a. So in this standard, we are representing 1 and 2 step problems. This was the hardest standard. You see 19.5% overall mastery. And if you take a look, I didn't miss a number here. Number 24, 8% correct. That was the lowest percent correct of any item on any STAAR test, grade 3 through Algebra 1 for 2023. So that was the hardest STAAR test problem that we've had here. So let's look at it real quick. What makes it so difficult? Well, first friend scored 339. The second friend scored 79, 75 more, right? So if that's all we're looking at, we're thinking, okay, so that's 75 more. Which chip diagram can be used to find the total number of both friends? Well, what did I just find? I just found the second friend. What did the first friend do? The first friend had this. So this one was 8% correct. You see, we had 49% of our students choose this one because it just found the second friend. Correct answer here is D, because this is the first friend, and then these two are the second friend. Number 7 wasn't a whole lot easier. We had 31% correct. And we had to have, a little bit of discernment here because we've got equations, we've got strip diagrams, and we have a number line here. So what do we have to do? A cafeteria had 280 ice cream bars. Some were sold. After lunch, 130 were left over, right? So when I see this, I'm thinking strip diagram, right? 280 is my total, right? Some were sold. And then the other part here, we got just your classic part whole is 130. So I'm going to use, 130 plus something makes 180. I'll probably subtract, right? 280 minus 130 equals my unknown. But you see here, this has subtraction, but it's got, these two terms, the subtrahend and the minuend, reversed, right? So that's, obviously not correct. And we had a decent amount of students choose that. That was actually the most chosen answer, 39%. And then this one really was a strip diagram, but it showed more of an addition of 280 and 130. And so this one was, 24% chosen by some because they understand strip diagrams. Not many kids chose this one, C. But the answer here is something that we probably don't spend a lot of time on, and it's a number line, right? So here's your 280. Some were sold. We don't know what this is, but we ended up here. See where we ended up at 130. So then we would have to count the distance from that 130 to 280 to see what that missing, difference is, which is the 150. So that was the correct answer. So what does all of this mean for us as educators? Well, first off, these were difficult because in that, number 7, we had to interpret the problem and then apply it to 3 possible different representations, the equation, the number line, and the strip diagrams. And for that number 24, what we talked about, that was one that was only 8% correct. The most chosen answer was step 1 of a 2-step solution. Remember, that was one where we had to find just the second student, right? Or the second friend. And they saw that. They saw, oh, that's good. I remember 339 plus 75. That's how I find it. That's only step 1 of 2. But that was one of our answers, and that was the most chosen answer, almost by half the kids, right? So down in the white font, we're going to see some instructional implications. What does this mean for us as educators? How do we do better this year? So when, number 1, we have students answer word problems for addition and subtraction, it's not enough to find the answer. In third grade, it is not enough to find the answer. You have to represent your answer and represent every single one. In an equation, they can probably do that. A strip diagram, with a little bit of support, they can do that, but this is the one that they're going to struggle with. But obviously, that was the correct answer on number 7. So they need to be able to represent their answer in 3 different ways. It's not enough just to find the answer, but they have to represent it. And then Honestly, this would have helped for number 24. Have them draw their own picture and use that before trying to solve it. So look how I solved number 24, right? I did it with some equations. Some people might have done a picture, right, with a strip diagram to show the three different parts. Some people might have just drawn, there's the first friend, there's the second friend, right? There's many different ways to do it. But we need to draw something. What happens when we see these problems and we see the four answers are representations, a lot of kids will just try to eyeball it. They just think, well, okay, the representations are down there. I just need to pick the right one. No, they need to pretend like these aren't here, solve it themselves first with their own representation, whether that be an equation, number line, strip diagram, then go and try to match the representation because then that gives them something to compare against. But a lot of kids are probably just eyeballing it, finding one that looks right because it uses the numbers. They need to draw their own pictures. All right, so our next struggling readiness standard was 3.7b, 27% overall mastery, perimeter. Only one problem here. But take a look. Vince had to build a fence around his rectangular garden. The perimeter of the garden was 26, so P equals 26. Length of the garden was 8, so let's just call this the length. And then here's my width. What is the width? Well, this is what I need to know. I need to know that perimeter is when I go all the way around. And if the top is 8, the bottom is 8. So what do I have so far? I've got 16. So out of the 26 feet that I need to go all the way around with, I've already used 10 feet. Or I've got 10 feet left over because I've already used 16 for the top and the bottom. But this is not the answer. Obviously, this is going to be, highly chosen answer. But what we need here is we need to take this 10, we need to split it in half because it needs to go one on each side, right? So that's going to be 5 and 5. And if we want, we could take your 8, your 8, your 5, and your 5. Double check, it does add up to 26. So our answer here is A. Now, what does that mean for us instructionally? Well, there was no visual support. It was just words. Have them draw a rectangle, right? They just had to kind of look at it and imagine a rectangle. And then the answer selections here, right? So on this particular number, you see that we've got 5 feet, 10 feet, 8 feet. Obviously, we see the 16. This is just you double the 8. Remember, they might have doubled it, right? And so we know where the 10 came from. The 10 is if you do the 26 minus 18. This 8 is just that number right there. And then, obviously 5 is our answer. So for number 21, the answer distribution was 27%, 21%, 19%, and 34% from A down to D. A lot of guessing. So they really didn't understand how to do it. And even, I'm sure part of this 27% just guessed. So what can we do as educators? Have them draw the rectangle like I did. First, get some kind of visual down there. Label it with length, and then the missing width, right? So that was 8, which means we know we can do that for 8. Then there's my W. There's my W. Now, what I didn't do, but what I should have done is put a W on both sides. So they know that there's two widths, right? It doesn't hurt for them to start seeing this formula. It's not on the reference materials yet. It will be on there next year. They do a lot with that, right? But this is algebraic thinking that we do in all kinds of substitution when they get into middle school and high school. And some, not all, but some students might be ready for this, right? So what did we know? We knew that P equals 26. And we knew that if you double the length, that would be 2 times 8 plus 2 times W. So that means 26 equals 16 plus 2 times, something, 2 times W. So most of them would be like, okay, that's going to be 16 plus 10. So 2 times what makes 10? 5. I mean, even without isolating the zero and using the properties of equations, they might be able to use that as a different way of solving this problem. 3.4K, 28% overall mastery, just one question. We're solving 1 and 2 step problems with multiplication and division this time. So this one's a little bit tricky. Martin has 11 cages. All right, so I would highly suggest when you see that number, just draw 11 cages. So let's pretend these are my 11 cages. Each cage can hold 7 birds. So I'm just going to say 7, 7, 7, 7, 7. Equal groups, right? If you want, you can do 11 times 7, right? That equals 77. The store had 21 birds in its cages. What is the greatest number of birds he can add to his cages? Okay, so it can hold, so these are potential birds, right? So then what I want to do, and I could change colors here, I want to circle the ones that actually have birds. 7, 14, 21. So those three already have birds, and I want to see how much can he add. Well, 7, 14, 21, 28, 35, 42, 49, 56, right? Or you could say, let's take away the 21 that already had birds. The answer here is 56B. Right, so let's see what that means for us as educators. What made it difficult? They had to recognize that the 11 and the 7 were multiplied together, but that third number, 21, was subtracted, right? And so some students might have been thinking you had to do this, which that would have been difficult, or this, which would have been difficult, right? Dividing by 21 at multiplying with 21, that's not going to work. So what that means is take a look at our answer selections here. We get a lot of guessing, and these are just random guessing. Uh, but I mean, look, 21%, 28% on that one. You had 24% and 26. That's as even as I've ever seen it. That's just pure guessing. We have no idea. So you can't be excited about the kids that got it right because maybe they did, maybe they did. So I think what messed them up is they recognized the initial multiplication problem, but they weren't ready to subtract another number. Okay. So what can we do? Well, like I did, draw the 11 cages. Always draw a picture. Have the students visualize the picture with some type of representation. And it doesn't always have to be a strip diagram or an equation. It could be an actual literal picture where squares or circles represent items, right? That was a little bit easier since we were doing equal groups, was to draw little rectangles to represent each cage. Now, check for reasonableness. So let's go back in here and let's just look. Let's just see what happens here. Let's erase this. What is the greatest number of birds that Martin can add to his cages, right? So if I know that I have 11 cages and 7 birds can go in each cage. Okay, so most kids got to 77. What is the greatest? Let's pretend we don't even know what this is. What is the greatest number of birds that Martin can add to his cages? We'll see how we automatically get rid of that one. Okay, so that doesn't make any sense. Now we're down to these three. Now, if we think of, okay, I'm going to add birds to the cages, and you've got to do this 21. If we think of using this number, to justify or to show reasonableness, this is where they might see that hidden operation. Okay, well, I need to make a pair. Those two make 77, but those two only make 35, and those two, right, they make 60. So this is where if we have them, if they're unsure, put their answer back in the problem, and to see which one makes the most sense. And they might see that those two make a pair of 77. That might help them as well. 3.4a. This is reporting category 2, 44.5%. We got two problems here. And as you can tell, we did pretty well on number 17. We struggled on number 9. So let's look at number 17. They sold 107 t-shirts and 88 sweatshirts. How many more? So that's a classic comparison. We're using subtraction. So we are technically subtracting across zeros, right? But obviously, there's no need to do this. That's just a 10, right? Just take the whole thing as a 10, see it as a 9. And so we're just testing our students' ability to regroup there. Most students are going to do okay. You see that 29 there. That's going to be chosen quite a bit as well. It's the most incorrect answer, but even then, 60% of our kids got this. So they've got that. Good job. It was this number 9 that really messed them up. So we got Miss Green. She's got some fabric here. And look at these numbers. I've got this and this and this, okay? So how many yards of fabric did she start with? Well, let's just add 69, 48, 53. Right, so that's going to be 1720. It's 10, 170, right? And that is not the answer because what am I doing with that 27 yards? Am I going to add that or am I going to subtract that? Well, look, I can do both. If I add it, that's 197. If I subtract it, right, that is going to be 143 right there. So this is where, once again, it doesn't become an addition or subtraction problem. It becomes a reading problem. So let's see what it says. Miss Green had 27 yards of fabric left over after making the costumes. How many yards of fabric did she start with? See, what is she doing with it? She's making costumes, making costumes, making costumes. And she had that much left over. So really what this is this is a part whole. Okay, this is 69, and then 48, and then 53, and then there's 27 left over. You got to put all those together. So my answer here is B, 197. Now, over half the students chose option A. Let's go back. Remember, only 29% got it correct. 51% of them just did this. Because visually, what do you see? Three numbers on the table. Now, is that really a third grade problem just to add three numbers? I mean, maybe, yes, we do practice adding columns of numbers, but honestly, three two-digit numbers, that's more of a second grade standard. So that should have been a little bit of a red flag. This seems a little bit easy. But there were way too many students, 51% of them choosing that. Only 29% chose the correct answer. So there was a trick there. They had to include that number, 27, that was not in the table in the starting total. And so that was the trick there. And almost a quarter of the incorrect answer choices on number 17 used addition, right? So number 17 wasn't as difficult, but this was the other one that was chosen, right? Or actually, it was either of these. This one just has no regrouping. But if you put these two answer choices together, you're going to get about a quarter of the students that they didn't even recognize this was a subtraction problem. So this is 185 is without regrouping, 195 is with regrouping. But they didn't recognize it as a subtraction problem. So what does that mean for us as educators? We need to have our students create their own representation to see if their representation matches the one provided, right? And so as I was reading this problem, you see how I created this strip diagram, and I noticed that there was a fourth part, this 27. So honestly, it would be much better if the table included this. And they need to create their own representation, as always, to understand what we're doing here on 3.4a. What we want them to do is to create their own representations. Next, we're looking at 3.5b, 47% overall mastery. We are representing and solving 1 and 2-step multiplication division problems. But you see, it's not just solve, but it's represent as well. So once again, we're getting back to that representing here. We need to represent addition, subtraction, and multiplication and division. So we did a little bit better on number 29. An artist painted 20 skateboards, right? And if we want, we can draw 20 skateboards. Let's, just draw an array all the way down here. Let's pretend there's 20 of them. She painted 4 flowers on each. So if we took the time to draw all the 20 little skateboards, we should be able to see, okay, so I've got 20 sets of 4. On each skateboard also gives us a clue that we're dealing with equal groups. Equal groups always lets us know we're going to multiply or divide, both of which are an option and both of which kind of work, right? You could do 20 divided by 4. That would get you a number that works. You could do 20 times 4. So our answer here is A, we want to multiply. But, these two don't really make too much sense. But 20 and 4, that's a basic fact. So I could see that being a potential problem for students. It was number 4 that really struggled, that really tripped them up a little bit. But look, we have a total of 32 magnets were attached to 8 middle cabinets. So when they give you the total, we need to understand where that goes on our strip diagram. See, I always draw my total on the top. You see how they draw theirs on the bottom. That's fine. were attached to 8 metal cabinets. So what we're do is we're going to just draw our 8 little boxes here. And then the question is how many magnets are on each cabinet? Well, when we see this right here, hopefully we see that it represents there. We should be thinking, okay, fours. All right, so let's just go 4 all the way across. So our answer there is B. Now, what does that mean for us as educators? Well, first off, for number 4, this one that we just looked at, all 4 strip diagrams use the numbers 8 and 32. So sometimes you can kind of eliminate one, right? Simply because it was, it didn't use one of the correct numbers. But look, this shows 8 times 32. This is 32 divided by 8, which is what we wanted. But this is 32 plus 8, and this is 32 minus 8. So they all use those two numbers, so we can't really eliminate any answers that way. And the distribution of wrong answers for number 4 was similar, so that 24, 19, and 17. So what that tells us is they either got it or they didn't. They had no idea and they were just guessing on these ones. And then obviously you don't know how many of them actually guessed correctly, but that means that students kind of struggled with identifying just the basic multiplication or division relationship that you saw there because you could have done either. For number 29, the answer distribution showed that students understood equal groups, right? So even though B was incorrect, right there, if you put those two answers together, A and B, that does equal 82%. So obviously, only 54% of them got this one, but a good chunk of the other students, right, 28% here got this. So that's good. That means they at least recognized equal groups here. They might not have recognized equal groups here, even though, I mean, it says an equal number of magnets, right? This is what we want them to do. We want them to cue in on those terms that give you a clue that we're dealing with equal groups, because that means multiplication and division, which means we should have been able to eliminate C and D. So how do we help our kids? So we need to help our students really understand, what we're looking for. Terms like total, equal number, the same number, and we're really looking for, can we find a total and can we find equal groups? If we can find that, that lets us know what type of strip diagram we are going to build. And then have students solve for the answer. Forget the picture, solve for the answer itself, and then substitute that into the representation. Because if I was able to solve, right, for this, obviously we've got the 80s right there, so I'm looking for that. But take a look at number 4. I never solved for it. I just said, okay, 32 divided into 8 groups. But if I know those are 4, right, then all I need to do is let's put a 4 in each of these question marks and see which one makes the most sense. And obviously it's not going to be A. That doesn't make any sense. That's 40. That doesn't make any sense, right? That needs to be 24, not just 4. So if you can solve it, then substitute that into the representation. That helps as well. And then they need to draw their own picture or strip diagram, just like we talked about previously. When you see all of these right here sitting right there, it's very easy for students to not draw their own picture or strip diagram. Same with the equations. It's all seems to be worked out and they just try to eyeball it. They need to ignore those, solve it themselves with their own picture or their own representation, strip diagram, equation, number line, then try to match the representation. Finally, we have 3.5e. So we are representing real world relationships. Take a look at both of these. They're both the same type of problem. These are what we call inline choice. So they have to answer these in a sentence and they have to, you know, choose from a multitude of answers here, right? So look at what we're doing here. Isabel selling clothing online, and it says that she sends a free gift with each order. So first we need to find the relationship. Create a sentence to describe the relationship, right? And hopefully we're adding one because it literally says they're doing a free order. So the number of items ordered, right? So we can fill this out, 5. So this had, different operations. The correct operation would be plus the number, different numbers. This would be the number 1. equals the number of items sent. So 5 plus 1 equals the number of items sent, 6. Or you can do 3 plus the number 1 equals the item 4, right? So it would be plus and 1 that gets you your full credit. And you see we only got 51% on that, 49% on number 19. Very similar. So the pet store had several aquariums, right? We need to describe the relationship again. So this time we're looking up and down, 3 to 18, 5 to 30, 12 to 72, right? So hopefully we see that we're going to multiply by 6. So in this case, we're going to say to find the number of fish, we are going to multiply, or we could say times, right, the number of aquariums by, and then you have to find that number 6. So there's similar type problems. Obviously, one is additive, one is multiplicative. So what does this mean for us? So the answer is given in text in both of these. No one is asking them to identify what's the rule plus 1. So if your work with 3.5e is find the rule, kids, that was insufficient for both of these. We don't need a plus 1 or a times 6. We need to write it in a sentence. And that's different. They had to interpret tables. One was horizontal, one was vertical. And then they had to, like I said, describe the relationship with the words. We noticed that the answer was actually given in the text there, right? Sending a free gift with each order, that's that plus 1. But it doesn't matter just to say plus 1. We had to describe it in words. So down in the white text, what are the instructional implications? So they need to answer once they find the rule, kids are pretty good at finding patterns. First, the first step is to have them answer orally. Describe the relationship with of the table with a friend. The number of items ordered plus the number 1 equals the number of items sent. To find the number of fish, multiply the number of aquariums by 6, right? These are two different sentence stems you can use. This goes straight from left to right. This goes from the answer and then goes back up to the actual problem itself. So these are good two good stems to find or simply replace this, with uh, your own problem that you're creating or having them work with. If they can say these sentences, then with correct stems, right, have fill in the blanks with whatever items you're looking at on your tables, that's a good scaffold. And then eventually you want them to do it in writing. Can they generate those sentences on their own? If they can generate sentences describing the relationship on tables on their own, they got this. I don't think the problem is finding the relationship. I think the problem is describing the relationship. And those answers need to include the specifics, the number of items ordered, the number of fish, the number of aquariums. Get away from plus 1 and multiply 6. The answer should be just multiply by 6. No, you need to include that in the context of the entire problem.